Right. So welcome back, everyone. In the last videos, I was discussing about the matrix transformation, and I just want to have a go over with what the transformation derivation, where I didn't clearly explain how we get the transformation, the general transformation. So um, let's head back and see what's happened, right? So when we transform, we're going to transform the vectors, the unit vectors, 1 comma 1, 1 comma 0, and 0 comma 1, according to the rules, the transformation, right? So what we're going to do is, the rule says x, y will get transformed into kx, comma y. If we apply these to the 1 comma 0, we would get, so remember k is a constant, so k is dilation factor from the y-axis. Right, just keep in mind about that. And this would becomes k times 1 comma 0. We are just changing the x multiplied by k, and the y remain as it is. And then the 0 comma 1 becomes, well, k times 0 comma 1, and this equals to k comma 0, that goes to 0 comma 1. Therefore our T was equals transformation matrix equals to k 0 and 0 1. That's how we derive the transformation matrix. But that's only, this is when we transform the unit vectors, or the unit vectors in the x and y direction. Now, how do we apply these to the general x and y, right? It's a bit, not quite straightforward to the general mind. So let's see. Let's say if I have the point, let's say if we get the point xy, for example, in a vector form xy, I could write this as x times 1 0 plus y times 0 1. So these are just so the 1 comma 0, that's in a vector form of the unit vector in the x direction, and 0 comma 1 is the vector form of the point 0 1 on the y axis. Now what we know is, so you can just do it for yourself and see these things are actually equal. So if I expand this, I'm going to get x times 1 is x times 0 is 0, plus y times 0 is going to be 0, y times 1 is y. If we add these two as we has expected, we still got x and y. So these two are saying the same thing, but just writing in different forms, so that we could utilize the transformation matrix into our favor, right? So let me continue here. So we can write xy as x times 1 0 and y times 0 1. And when we transform these into by the transformation matrix, just to clarify what I mean by that. So when we transform the point, I'm going to put t 1 0, right, by the factor of k, by these factors, that becomes k0, and when we transform the point 0, 1, it remains as it is because we can't move. We don't get any dilation from the y-axis because we're multiplying by the k by 0, the x value. So that means we could do the following. Let's transform the general x and y points, right? So this is what we will get. So if I transform the general, so this is general transformation of the point x, y, not just 1 and 0 and 0 and 1. We transform the whole x and y, any points, okay? So I'm going to do that. So if you transform t of x, y, it becomes, well, I'm going to replace, instead of x, y, I will replace the x, y by, so this x, y will be replaced by this. I'm going to use this expression, all right? So they're the same. Just make sure that you don't confuse with what I'm writing it down. So t, remove that for now. You're going to get t, the same t. And instead of x, y, we're going to put the expanded form x, 1, 0, plus y, 0, 1, okay? And I will call these transformed x, y, let's call these the new x and the new y's and write in the following way. X dash, y dash, that will be, now remember x and y, these x and these y are constant, right? They're constant. So we could pull them out and get the following expression. X, so I'm the transform, or before that I should do the following. So you could, this is the same as, well, the transformation is a linear operator, meaning so you can split the between addition and subtraction. So t times x, t of x 0, 1 plus t of y, oh, I put the wrong way around, sorry. That should be 1, 0 and 0, 1, the wrong way around. And 0, 1, okay. And since x and y are constant, we could get the following expression. X t of 1, 0 plus y t of 0, 1. And we know t of 0, 1, t of 1, 0 is equals to k0, and t of 0, 1 is equal to 0, and it doesn't change. So this is what we get. So instead of that, we're going to get x times k0 plus y times 0, 1. And if we write this into a matrix form, so these are x dash and y dash, x dash, y dash, we could write the following. We could write this as k 0, 0, 1, x, y. So the equivalent expression in the matrix notation, and this is what we get, x dash, y dash. Okay, so this is the full derivation of my previous videos where I just use the, assume that t is equal to k0 and k0 and 0, 1, and times it by xy. We just put it that way without explaining how I reached that conclusion. And here it is, you could see that, and we can write this one as t, that's t, the first one. This is t, that's t, and that is x. And we will call this thing x dash, that's t, and that's x. So there you go. So I'll just put a box around somewhere and write in green. It would be x dash, squeeze it in, equals to t times x. Okay. All right, and we'll do some example in the coming videos. Sorry, it took me a bit to explain the whole process through. All right, stay tuned and more videos will come.